Hello, this is Math 1960, Section 301. We want to complete the problems that we were not able to discuss in the previous lecture. So here is this function. We want to integrate it. Now, if I ask you to integrate this function, it's very hard to integrate. Okay, so the only way to integrate this function is to decompose the function into smaller fractions. And by doing so, we are able to integrate the function efficiently and correctly. So here I have this rational function. I'm going to decompose. I do the decomposition. So I have x minus 1 squared. This is a linear function. This is a linear function, but this is a repeated linear function. So I'm going to use the rule that was described in the table. So here I'm going to have a over x plus b over x minus 1 plus c over x minus 1 squared. And then now we multiply both sides of the equation with x times x minus 1 squared. So then we're going to get 1 equals to a x squared minus 2x plus 1 b times x squared minus x plus cx. So 1 equals to a x squared minus 2ax plus a plus bx squared minus bx plus cx. So these are the equations that we're going to so for instance, we don't have x squared on this side, so that means x squared is multiplied by 0. All right, so here I'm going to have a plus b, and then we don't have x here, so we're going to have negative 2a minus b plus c is equals to 0. And then we have a here is equal to 1. So we have a equals to 1. This is x raised to the power of 0. And here we have x raised to the power of 0. And then if we solve these three equations, we're going to get c equals to 1 and then b equals to negative 1. So now we are going to integrate the following. So the integration is going to look something like this. 1 over x, because a is equal to 1, minus 1 over x minus 1 plus 1 over x minus 1 squared dx. So if we take the integration, this integral here is going to be ln of x. And that integral is going to be negative ln of x minus 1. And that one is going to be equals to negative 1 over x minus 1. So we're going to use u substitution here, plus c, the constant. Okay. So also when we do if we want to integrate this function here, first of all we want to break this function into smaller fractions. So the way to do that is using partial fraction decomposition. So we have 3x over x cubed minus 1. So that would be equal to 3x over x minus 1 x squared plus x plus 1. So that then, this is difference of cube. So we can factor it this way. So this is going to give me something like the decomposition would be a over x minus 1, because here I have irreducible quadratic function. I'm going to have bx plus c over x squared plus x plus c plus 1, sorry, plus 1. Okay, so now we are going to multiply both sides of the equation with this. So then I'm going to have 3x equals to a x squared plus ax plus a plus bx plus cx minus bx minus c. So a minus c equals to 0, and then 3 equals to a minus b plus c. So we have a plus b equals to 0. So then from here we would find c equals to 1, b equals to -1, and a equals to 1 by solving these three equations. Okay, so now, my decomposition we would integrate the decomposed function, which is equal to 1 over x minus 1 dx plus the other function 1 minus x over x squared plus x plus 1 dx. So then this function here is going to give me ln of x minus 1 plus c1. And then this function here, we're going to integrate it, and we use the u substitution. So we're going to have 1 minus u plus 1/2 over u squared plus 3 over 4. First of all, I complete the square. So when I complete the square here, I'm going to have 1 minus x over x plus 1/2 squared plus 3 over 4. This is by completing the square for that for the above function. When I complete the square, then I say u is equal to x plus 1/2. And then now I substitute in here du. So then I say du is equal to dx, you know. And so here when we do the integration, so here we're going to have integral, so it's negative u over u squared plus 3 over 4, and then this is du, and then integral of 1 over u squared over 3 over 4 du. So when we take the integral, this is going to be positive here. No, this is going to be negative. This is going to be positive. So when we take the integral of this one, we should get ln of it's going to be 1/2 ln of u, which is basically u plus 3 over 4, which is basically x squared plus x plus 1 plus c2. And then integral of this one is going to give me the tan function. This is going to give me some sort of a tan function. 3 over the square root of 3 tangent or tangent inverse of 2x plus 1 over the square root of 3. This is plus c3. So the overall should be equals to ln of x minus 1 minus 1/2 ln of x squared plus x plus 1 plus square root of 3 tangent inverse of 2x plus 1 over square root of 3 plus k. Okay, so regarding problem number 5, since we may have no time, we're going to just set it up, and when we set it up we can give you the final answer. So problem number 5, we want to decompose of this function. So the composition of that is going to be x cubed plus 1 over x squared over plus 4 all squared. This is irreducible quadratic function, but it's repeated. So decomposition of that would be equals to ax plus b over x squared plus 4 plus cx plus d over x squared plus 4 squared. And then when we cross multiply, we're going to get x cubed plus 1 equal to ax plus b times x squared plus 4 plus cx plus d. Then that is going to give you something like ax cubed plus 4ax plus bx squared